Okay, in this video, we're going to go over basics of dimensional analysis. We're going to start with converting one unit directly to another. Now, and then we're going to go into what happens when there's fractional units, meaning one unit on top of another. And so we're basically converting two units at a time, a derived unit. Now, in dimensional analysis, we can be converting units that are in the same system, such as metrics, or we can convert units that are in different systems, such as metrics to standard, or we can be converting things that are just related to each other, such as pieces of pizza per student, or dollars per pound of horse that we're selling, or pound of pig, or it can be anything that is related to anything. So in our first problem, we're going to convert kilometers to miles. So we go to our conversion sheet, which I gave to you, and I told you that we were going to be looking down at the bottom here. We go to our conversion sheet, and what we see is that 1.62 kilometers is equal to 1 mile. And when we talked about this, we said that when we had these conversions, the numbers needed to stay with the units. And this is super important. So when we're doing this conversion, we're going to keep that 1 with the mile and 1 with the 1.6 with the kilometer, 1.62 with the kilometers. So we're going to start with the 7.72, and the reason it kilometers, and the reason is because when we're converting, this is a little bit like a journey, and so we're going to say, where are we starting and where are we heading to? So in this case, we're heading to miles, and that's where we're going to end up. We're going to end up in the units of miles, and we're starting with 7.72 kilometers. So we're going to draw our boxes, and some teachers use fractions, but I use boxes. It's the same process, it just looks a little different. And then we're going to ask ourselves, what unit goes down? What unit goes down? And so we look and we see the kilometers is up here. And so that unit is always going to go down. Whatever unit is up top is going to move down. And that's important because the units, they drive the process. So the unit that's up top moves down here. And that's important because then when we look up here at our conversion, we see that the kilometer is here and 1.62 is with it. So we put the 1.62 here because the 1.62 kilometers is here and the kilometer came down here. So that means the only thing that's left here is the 1 mile. All right, so we're going to now be able to cancel out our kilometers. And the reason is because top and bottom cancel, just like in fractions, top and bottom cancel. So when we do that, and we actually don't need all of this here, because that's extra. No, we don't need this. So when you do that, you end up with this T, right? And that T has mile, just mile is sitting here all by itself. Mile is sitting there all by itself because the kilometers have been canceled out. Now, the thing is that, again, the nice part about this is that when we lay out this conversion, each side of the equal sign represents the top or bottom of one of our conversion fractions. So the mile could be on the top or the bottom, and the 1.62 could be on the top or the bottom. So then what we're going to do is we're going to use our calculator. I have my calculator. And we're going to take, for our math, we're going to take 7.72 divided by 1.62. And that gives me that number, which I'm going to round off to 3 places because somebody measured this and rounded it off, and somebody measured the 1.62 and rounded that off to 3 places. So I'm going to get 4.77. So 4.77, and then the units is miles. Okay, so that's the answer there. Now, let's take a look just real quick at something. So here, when we were talking about the number must stay with the unit, so let's talk a little bit more about this. So I could have one truck, and I could put it with 4 tires. And I can flip this, and I can say 4 tires with 1 truck, and that also will be acceptable. But what I can't do is flip the unit without flipping the numbers. So what I can't do is say for one tire with 4 trucks. That is not acceptable. And what I did here was I flipped this, but I didn't flip the numbers. So the 4 is still on the bottom. And that's not acceptable. So that won't work. So what this means is that the units must stay with the numbers. And this is going to be very important later when things get complicated. It's going to be very important, and it's going to seem really obvious for a long time, but then it's going to get really complicated, and I'm going to say to you in class over and over again, the units, the numbers and the units must stay together. So this is really important. Okay, let's move on to the next one. So here, the 1 and the mile have to stay together, and the 1.62 and the kilometers have to stay together. Let's move on to the next one. Now in this problem, I'm going to ask that you change the 5.58 to 1.6. So we have here 5.58 grams, and we'd like to convert that to milliliters. And what we're given is the density of 1.6 grams per milliliter. Now, anytime you hear the word per, that means fraction bar. So there it is, per milliliter. But it also means that we can set up a conversion like this one up here. So I can say 1.6 grams is equal to 1 milliliter. For our purposes, that's going to be equals. And so once again, we've set up our great little boxes here that say I'm going to be either the top or the bottom of the conversion fractions. I'm not sure which it's going to be, but it's going to be the top or the bottom of the conversion fraction. So I'm going to start out with the 5.58 grams, and I want to go to milliliters, so I'm going to make my box, and then the question is, what unit goes down? So in this case, grams will go down, and I'll put grams down here. And then I look up at my conversion, and I see that 1.6 is matched with grams, so 1.6 goes here. And the other side of this equality is 1 milliliter. Now remember, this equality here came from here, 1.6 grams to 1 milliliter. So this density was turned into an equality that I can use for conversion from mass to volume. So I'm converting from mass to volume here. Given that I have 5.58 grams, how many milliliters is that? Mass to volume, question mark, right? So now I can cancel out my grams, and here I am with milliliters. So that's great, because I want to solve for milliliters. I put my milliliters here. I use my calculator. $5.58 divided by 1.6, and I get 3.4875 times 10 to the 0, but I only have 2 digits to work with. And the reason is because although the 5.58 is 3, the 1.6 is only 2, and somebody did measure that many grams when they measured out 1 milliliter. And so I can only have 2 digits, so the answer is 3.5. So 5.58 grams of that substance is 3.5 milliliters. So next, I'm going to go to how many inches are in 1 meter. Now notice this 1 is written as a word, so I'm not going to use the number for my sig figs at all. Not at all, because the word tells me that it's super vague and nobody cares about it for sig figs. So I'm going to go, the end of my journey isn't going to be inches, so I'm going to end in inches, which means I'm going to start with 1 meter. So I'm going to look in my conversion chart, and I'm going to look for conversions that would be helpful. So definitely what would be helpful would be 1 inch is equal to 2.54 centimeters. And then, because you don't have it on your conversion chart, what I am going to tell you is 10 to the 2 centimeters is equal to 1 meter. So that will also be helpful, even though it's not on your conversion chart. I'm going to give that to you. Now, when we write this down, what I have done is I've set up, top or bottom of a fraction, and then top or bottom of that same fraction. And over here, top or bottom of a fraction, and so I made a mistake here. This is centimeters to meters, so this should be meters, and this should be centimeters. So if you look at your, no, that's right, never mind, I take that back. 10 to the 2, 100 centimeters is equal to 1 meter. That is correct. 100 centimeters is equal to 1 meter. Sorry, so that is correct. Okay. So I gave you this. Now, this is not the way you will do this, that we've been doing this in class, or that we will do it in class, but I'm just giving you this as a quickie conversion so that you can do this problem. 100 centimeters is equal to 1 meter. Okay. All right, so here we go. First, I'm going to start with 1 meter, and I'm going to end with inches. So here's my 1 meter. What unit goes down? Well, the meter goes down, so 1 meter goes down, and then what's going to go on top is 10 to the 2nd centimeters. So then I'm going to ask again, what unit goes down? So centimeters is going to go down. How many? Well, I look at my conversion here, 2.54 centimeters, and what's on the other side of it is 1 inch. So now I can cancel my centimeters, cancel my meters, and what's convenient is I'm left with inches, which is great because that's what I want. I get my calculator. 1E2 divided by 2.54. And I get 3.94, because I'm going to get 3 digits. This is a definition. 100 centimeters is just defined as 1 meter. So I get 3 digits for the 2.54. So I get 3.94 times 10 to the 1. 3.94 times 10 to the 1 inches. So there's 39.4 inches to 1 meter. All right. So now what we're going to do is we're going to take this and we're going to go to a top and a bottom at the same time. So tops and bottoms can cancel. And we can run them at the same time. So here's an example. Convert 47.3 miles per hour to kilometers per minute. So I'm going to end at kilometers per minute, but I'm going to start at 47.3 miles per hour. All right. So what conversions might be useful here? Well, miles to kilometers, 1 mile is equal 1.62 kilometers. And then hours to minutes would be useful too. 1 hour is equal 60 minutes. That's also useful. Now, each one of these sets up its own top or bottom, right? Top or bottom, and then top or bottom, and top or bottom. So that's super helpful. And now, let's see, we're going to start with 47.3 miles per hour. And I can pick either one. I can start with miles or I can start with hours. I can pick either one. And I'm going to do one at a time. So I'm going to start with miles. And so what unit? Well, actually, I'll start with hours. And so what I would be asking is, what unit goes up? Because in order to cancel out my hours, I'm going to need to put it on top. So hours, here's my conversion. 1 hour is 60 minutes. 1 hour, 60 minutes. And when I do this, I can now cancel top and bottom. I can cancel hours, which means that minutes is going to be my unit on the bottom. And there it is, minutes on the bottom and minutes on the bottom. And I like to circle my units when I'm finished because that way I know my bottom level is done. Next, I'm going to do my miles. My miles are on top, which means they're going to go down to the bottom. And then I look here, miles to 1.62 kilometers. 1 mile to 1.62 kilometers. Miles cancels and miles cancel. So now I'm going to use my calculator, and I'm going to say 47.3 times 1.62 equals divided by 60. And my answer is 1.277. I have 3 here and 3 here. I don't count this one because this is a definition. Someone defined 60 minutes as 1 hour. So I'm not going to count that one. So when I round off here, I get 1.28. So my answer is 1.28 kilometers per minute. And that's my answer. Okay, we're going to do one more double. My car gets 25.7 miles per gallon. So there's that per again. So that means fraction bar. So 25.7 miles per gallon. If I can move to Europe and I ship my car there, how many inches per liter, there's that fraction bar, will my car be getting? So the question is, how many inches per liter will my car be getting? So this is where I want to end up, is in inches per liter. And this is where I'm going to start, is in 25.7 miles per gallon. So what conversions would be helpful? I go to my conversion chart. Do I have a miles per inches conversion? No, I don't. But what I do have is I have 1 mile equals 5,280 feet. I do have that. And then I have 1 foot is equal to 12 inches. I do have that. So that'll get me from miles to inches. Now I need to get from gallons to liters. So I go to my conversion chart. And what I see here is that 1 gallon is equal to 3.79 liters. So that's super helpful. So 1 gallon is equal to 3.79 liters. All right, I think I'm ready to go. Each one of these, in their own way, is either a top or bottom of the same fraction. So each side, top or bottom, 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 okay? You can't mix them, but, so top or bottom, and then what's left over. Top or bottom, then what's left over. All right, so I'm gonna start with 25.7 miles per gallon. I'll start with the bottom one, all right? So I'm going to start with, actually, I'll start with the top one. How's that? I'll stop with the top because I started with the bottom one on the previous one. So 1, what goes down? Miles. 2, 5,280 feet. So now 1 mile, my miles cancels. What goes down? Feet. What goes up? 12 inches. See? 1 foot, 12 inches. Now I can cancel my feet. Next, inches go down. No, it doesn't, because that's where I am. So I'm done. Inches, that's what I wanted. Next, gallons to liters, because I want to go to liters. So what goes up is gallons. And 1 gallon is equal to 3.79 liters. 3.79 liters. Now I cancel my gallons, and what's left is liters, inches per liter. So now I'm going to use my calculator. We're almost done here. 25.7 times 5,280 times 12 equals, divided by 3.79. And I get 4.296 times 10 to the 5th. So how many digits do I get here? I have 3 here. This one is a definition, so I don't use it. This one is a definition, so I don't use it. This one is 3. So that means I'm going to get 3 in my answer. So I have 4.296. I'm going to round that 6 over. So 29 becomes 30. So 4.30 times 10 to the 5th. So my answer is 4.30 times 10 to the 5th inches per liter. Okay, so that's how you do dimensional analysis. That's how you do singles and doubles. Now, there's practices on the worksheet, and then we'll be doing more of these in class.